All right, 5F. Here we go. So this goes back to everything that you've done so far. Chapter 4, reading your properties. So you've learnt your log properties, you've learnt your exponential properties. Looking at this equation, we can tell it's an exponential. Whoops, what's going on there? All right, there we go. That's an exponential graph. Plus B is my translation, vertical translation. Reading the graph, I can see there's a vertical translation, there's an asymptote. So what should B be? What is B? Let's go with Alex. Just look at the graph. Not 1. Anyone else who knows? 4. Why 4? Because we've got the horizontal asymptote at y equals 4. Thanks, team. So we knew this had to go up or down. Clearly from the graph it's gone up by 4. Okay, the graph has gone up by 4, it's an exponential. We can also see that the graph is a reflection from the x-axis, so likely A has to be a negative. So how do you find A? They've given you a point, and just like every other exercise you've done, you can write in now, y is equal to A times e to the power of x plus 4, because we know there's an asymptote that goes up by 4. How do you find A? Sub a point. They've given you 0, 2. Sub 0, 2. Here's what we get. 2 is equal to A times e to the power of 0 plus 4. E to the power of 0 is 1, so A plus 4 is equal to 2. A must equal to negative 2. Okay, which is what we predicted. We said there had to be a reflection, and we can see there's a reflection. Okay. Example 2 is exactly the same, but I'm going to leave that for you guys to do because that's what exercise 5F is. Okay, so 5F is about you looking at a graph and then figuring out the properties. Now, the last question, I want you to copy this down because this one is a bit trickier, but I'm going to give you a few minutes to have a go first. Can you flip over to the last page? Example 3. I want you to have a go with example 3 on the back page because example 2 and 1 you can do without me. Let's pause the video. New recording. So what I would have done from here is I would have done equation number 2 divided by equation number 1. So I've subbed it in. Why did I do 2 divided by 1? Because 4 divided by 2 gives me a nice whole number. 4 divided by 2 is 2. And then what you notice here is I'm saying A times log 2, 7 minus B divided by, and what nicely happens here is log 2, 5 minus B, the A's cancel out. A divided by A is 1. So I've eliminated one of the variables. This is kind of like how you do with add, subtract. In this case, you don't have to. You're dividing. So that's the first step. You all should, if you did it correctly in some way, whether you substituted, so if you rearranged the first equation and subbed it into the second one, still works the same, you would have ended up something similar to what I have here, where you would have 2 is equal to log base 2 of 7 minus B divided by log base 2 of 5 minus B. Let's assume you took this approach. We got rid of the A's. So what do we do now? So first step was I sub the coordinates in. I get 2 equations. I know simultaneous I can do division because I can divide both sides by 4. So I divide this by 4, divide both sides by 2, divide this by 2, divide this by 2. And I'm essentially dividing by that. That's what elimination is. I got rid of A. Now what? No, there isn't. That's the first common mistake most students do. We only got log law add, log law subtract. We do not have log law divide and times. So what do we do now? You could, that's true. I didn't even think of that. You could do that. I normally just get rid of fractions. That's the first thing I do. I just rearrange them, right? But yeah, you could probably try to do it that way actually. Let me just think. Well, you probably could. What I would have done, I'm just going to show you what I just didn't think of the alternative. I have to think about the alternative approach here. What I did was get rid of fractions. If you don't like fractions, get rid of them. How do you do that? Opposite of divide is times. Times both sides by log 2 of 5 minus B. Now, if I do that, just removes each other out. You get now 2 times log 2 of 5 minus b is equal to log 2 of 7 minus b. There is one key step here that is very examinable that they usually do in exams. I can't solve this yet, but I can do one small thing that makes it possible to solve from here. Very good. Move the 2 as a power. That's log rule number 3. Log rule number 3 is a very typical exam technique that they always do. So if you do that, you get now log base 2 of 5 minus b all squared. I should use square brackets to show the difference. And that's equal to log base 2 of 7 minus b. Now, why do we like that? Is because both sides have a log base 2. And if you want to get rid of a log base 2, the inverse of that is exponential base 2. So if I said 2 to the power of the left, 2 to the power of the right, these two are inverses. So you essentially end up with a quadratic. I know examiners love quadratics, don't they? So here we go. 5 minus b squared is equal to 7 minus b. All right, team. So from here, now it should be a bit smooth sail. So that was the toughest part. That's what they'll look for the first mark. All this is still 1 mark. Okay, you haven't got to your 2 marks yet. From here until you solve for b, that's 2 marks. So here, how you normally do it, bring all the b's together. So in this case, expand it. Perfect squares, expansion of perfect squares. That's what? 25. That's a b squared. That's a minus 10b. I've just done it a bit quick. Hopefully you can expand perfect squares. All right, and then 7 minus b. Move all the b's together, move all the numbers together. What's that? Plus 1, so minus 9b. Minus 7 is 18. All right, team. Factorizing. Chapter 4. That's a nice one. It's a monic trinomial, so you should be able to get b. What's this? 6 and 3? Is it 6, 3? Minus 6, minus 3. Yep, that works. Therefore, b is equal to 3 or 6. 2 marks. This is first mark. Oh, sorry, that's the second mark. This is your first mark. Where'd you get up to get your first mark? Up to here. So if you can get up to that step, that's 2 marks already. But remember, I said this is a 3 marker. So in an exam, you need to check that. You need to check that, yes, you've done all that hard work. You get to b equals 3 or 6. But you have to check, does it make sense in the equation? One of the restrictions of log is they can't do log of a negative number. So let's check it. If b was equal to 3, then I would have in equation 1, I would have 2 equals a times log 2 of 5 minus 3. That's okay. 5 minus 3 is okay. So this is possible. You get a times log 2 of 2. Which actually works out nicely. It's 1. So a equals 1. That's if b is equal to 3. Okay, so 5 minus 3. So I just took 3, subbed it back here. 5 take away 3 equals 2. Log 2 of 2 is 1. A times 1 is a. And then therefore a equals 2. Wait, where did I get the 2 from? Oh, yeah. Cool. All good. But if you test 6, if b equals 6, what's the problem? Log 2 of 5 minus 6. A times log base 2 of negative 1. Right there is your problem. Therefore, b can't be negative 6 because then log 2 of negative 1 does not exist. It's undefined. That's why that first 2 parts is a 2 marker. And your third mark comes from checking, knowing that this is undefined. Therefore, b equals 6 cannot happen. So that must mean a is equal to 1 and b, 2. My bad, 2. A equals 2. Was that a nice question? So these type of questions, when you get to log and exponentials, elimination method, simultaneous, think of times and divide. If you try to add and subtract, you just go around in circles because they can't cancel out. All right, so division or multiplication is the tip. All right, team, that's all I wanted to make sure that you see, so at least you have an idea of that kind of problem. The rest is your time. You've got about 25 minutes of your time. I'm going to start the video.